So thank you all for coming to this session. There is somewhat of a difference between the talk title and the abstract text. I don't know if anyone bothered to read the abstract, but this talk is actually going to be about what was in the abstract and less about what's in the title. It is big data beyond the JVM. If you are like really super interested in machine learning, this is still applicable, but it's not super directly focused on machine learning. These things are important for supporting deep learning in Spark and other important machine learning changes that are coming, but it's more looking at the ecosystem as a whole and how things are going to be sort of outside of the JVM and how we should work together. Oh yeah, clicky button. Oh man. Does someone want to make it go to the next slide? Oh yeah. Well, in the meantime, I can introduce Boo. Her name is Boo. She is my travel companion. She comes with me to most of my talks. And thanks to the wonderful people at IBM, Victoria Gomez, I got this nice little Spanish bull thing. I don't have a name yet, but Boo really likes having a travel friend. Oh, okay, cool. Clicky button works again. Yeah, okay, so my name is Holden. My pronouns are she or her, and I am an engineer. Oh, wait, oh, come on. Okay, whatever. I'm an engineer / developer evangelist at Google, and okay, cool. Previously, I was at IBM about 3 weeks ago. Before that, I was at a bunch of other places, including Google, again, but also Databricks and Alpine and some other fun people. I'm going to bring Boo over here with me, and she's going to, oh no, okay, oh dear, I'm sorry, okay. They're going to come with me because I can read my slides if I'm standing over here. So yeah, I'm a co-author of a few books on Spark. The latest one I got a much better royalty deal on, so I think that's the best Spark book out there. One copy of that book buys me about 1/4 of a cup of coffee in San Francisco. Yeah, if you want to follow me on Twitter, it's just my name. The slides from today's talk will go on SlideShare, and I have LinkedIn. I really don't know why I put this in my slides, but whatever. Yay, okay. So outside of work, I'm trans, I'm queer, I'm Canadian. I live and work in America on a work visa, one which is actively being debated if they want to continue having it. And I consider myself a part of the leather community. And this is just a reminder that we all come from different places. Some of us may be more visibly different than others, but we should all try and be friends. We all get the same out-of-memory exceptions. We all write the same shitty Spark code, right? And if we work together, we can go home sooner, or at the very least, we can build more inclusive systems. Clicky button. Oh, come on. Clicky. Yay, okay. So this is Boo, but we already did her introduction. She's also on Twitter if you want to follow her. Her tweets are generally less depressing than mine. So I'm hoping you're nice people. I'm hoping you don't mind pictures of cats. If you do, this is not the talk for you. I am really curious, though, and I can't see super well beyond the first few rows, so don't feel overly obliged to participate. How many people know Scala? Oh, wow, that's a good number of people. And how many people know Python? That's a good number of people, and I'm happy to see some overlap. That's really lovely. And my slides seem to be advancing on their own, so that's wonderful. So what is Spark? Spark is a general-purpose distributed system. It has a bunch of different APIs, including a Python API, and the things that we did to make that happen are kind of sad, but in comparison to what other big data systems have done, they are not that sad, and they can get better. Come on. Okay, Spark-specific terms in this talk. RDD, you can just think of it as a distributed collection. Dataframe, we'll actually use it in two different meanings, one of which is the data frame which you're familiar with probably, which is pandas. Those things are happy and wonderful, and our data frames. The other one is the Spark data frame, which is just kind of a letdown if you're coming from the pandas world. You can think of it as everything you like about the pandas data frames, but without any of the functionality. And dataset is Spark's realization that types are useful. Okay, so we're going to talk about some of the options for doing big data work outside of the JVM, not just in Spark, but then we're going to go ahead and we're going to do sort of more of a deep dive in how PySpark works, why it isn't good enough, and why things are finally changing. And I'm going to, of course, try and get you to buy my books. Okay, cool. Oh, damn it. Okay, so what is the state of non-JVM languages in the big data ecosystem? So most of the tools are built in the JVM, at least initially. Hadoop MapReduce, Spark is Scala-based, but still runs in the JVM. Kafka is largely JVM-based, although it has APIs in other languages. And so a lot of this ends up being our data is first accessed in the JVM, and then when we want to do something cool with it, like maybe do some cool deep learning, we end up having to take our data out of the JVM and put it into this other more specialized system. And historically, this hasn't been a big concern for the people developing the software itself. They've just been like, well, I have some Python users, but they're not me, so I'll just get it working well enough that we can go from there. But now this is actually changing, because now the Python people have libraries that the Java people want to use, and they're like, oh, well, I guess I need to make this work better. And so that's the state of the world that we're in. The other one is not all big data projects are written in the JVM initially. Dask is a really awesome project. It gives you a really nice data frame-like API, and it's sort of a pure Python project, insofar as pure Python projects are mostly written in C++, but it's, at least mostly outside of the JVM. Yay! Okay, so streaming Hadoop is Unix pipes, and that's just sad. But it turns out that Unix pipes work better than you would think. And in part, this doesn't matter as much because MapReduce is already really slow. And so when you're driving, I don't know, what's a really bad car that people drive over here? I don't know. Okay, I ride a 150cc scooter, and I sometimes take it on the highway. And so when you're riding a 150cc scooter on the highway, it doesn't really matter if you've got the throttle open all the way. It's just not going to go that fast. So Hadoop streaming is kind of bad, but MapReduce just wasn't going to be all that fast on its own anyways, so we don't tend to notice the incremental badness. So the other approach, if we're wanting to work with streaming data, is Kafka. And Kafka is really awesome and wonderful, and it's built into the JVM. But because the client libraries connect to it over sockets, we're not restricted to having to use a JVM client library itself. And this is really awesome. It means that if we want to work in the JVM, we can use the JVM clients. But if we want to work in Python and do some live serving, maybe we've got a TensorFlow model we want to serve out of Python, we can totally do that. We can just subscribe to the Kafka topic and do our cool things. The only downside of this is the primary developers of Kafka tend to work in Java. New features for the clients tend to get implemented in Java first. And eventually, maybe if someone will pick it up and port it into the Python client later. And we don't have access to all of the cool features that the JVM kids do. But we can still, pretty easily get out our data and do things with it. Okay, this clicker is less reliable than a Spark cluster running on Spot instances. It is painful. So Dask is really awesome. And it's a pure Python implementation, and it provides a real enough data frame interface for distributed data. And I don't really work on Dask that much, and so this is probably part of why I think it's awesome, is because I haven't looked at its internals to the same level I have of Spark. And with all software, once you truly understand it, you truly understand how bad it is. But Dask actually works pretty well, and people seem really excited to use it. It has some challenges, though, and part of it is because it's written in Python, it has difficulty interoperating with a bunch of the other things in the Hadoop ecosystem. So if you've got a bunch of Parquet data sitting in HDFS, getting it into Dask can be a little slower than it is in other systems, or at least more frustrating. But if you're just like starting a greenfield project and you're not in an existing Hadoop space, Dask can be a really interesting option. Clicky button. Yay! Beam. Beam is a project. It's an Apache project, open sourced initially by my new employer. Yay! Thank you for paying my salary, Google. And honestly, if I was a better employee, I would tell you about all of the awesome ways that Beam Python works. But it doesn't work really outside of Google's hosted environment for the Python integration, so we're just going to kind of skip over that. But if anyone's like really excited about Beam, I would love to talk with you, and you should go definitely see Tyler's talk later on today. We have some really interesting plans to unify the runners, but the code doesn't exist yet. So while we would love your feedback, if you try and use it today, that's just going to not work out so well. I mean, Beam itself is fine, but the Python integration is not there. Damn it. Come on. OK. Back. I think there was one more slide back. OK, God damn it. Where? The slide clicker. I'm sorry. OK, so PySpark is the Python interface to Spark. And the technique that's used to make PySpark work is roughly the same technique that's used for the C# interface to Spark, the R interface to Spark, and the Julia interface to Spark. And it's also sort of the same general technique which you use when you want to integrate with third-party libraries that don't run in the JVM. It's relatively mature. It integrates well-ish into the ecosystem. It does have not a very Python-rific API, which is unfortunate. You definitely feel that you're writing Spark code when you're writing Spark code. And it has some pretty serious performance hurdles that we're going to talk about how we're working to overcome. And yes, of course, it has word count. Yay! Everyone loves word count. As a licensed big data instructor, I must put word count in every one of my presentations. I left it out once, and they threatened to take my license away, so I put it back in. And so here we can see a really, really simple word count example in Spark. We load some data in, we tokenize it, we do all of our fun stuff. And the interesting thing to note is these are all Lambda expressions, right? These are all just anonymous Python functions that we're passing into Spark. And Spark itself is running in the JVM, so it has to find some way to evaluate these Lambda expressions for us. And this is roughly what PySpark's internals look like, which in America is called a lawsuit. That was a joke. Damn it. This clicking machine. I want to throw this in that. Anyways, OK, so Spark is written in Scala. How do we actually make it work? So we use this library called Py4j. Has anyone used Py4j in the audience? Anyone? 0 people, as far as I can tell. OK, well, you're all very lucky people. Py4j is a really wonderful library in that it lets me do things that I can't do otherwise, but it does raise a question of why I'm doing them. And so it allows me to call Java from Python and vice versa. It's not very fast, but it lets me do those calls. The other part that we use is we tend to serialize a lot of data from Python, shove it into the JVM, and vice versa. And so we use pickling. Sometimes we use JSON intermediately just because pickling seemed like a lot of work. As far as I know, we do not depend on any XML, but if I find it, I would not be overly surprised. And the magic is the part which tends to break. But it works. Spark SQL, which is the new data frame interface in Spark, avoids some of these problems. And so essentially, instead of having distributed collections of opaque strings that the JVM cannot understand, it has distributed collections of things that the JVM actually knows what it's doing. And if we write our expressions in a certain way, we can actually take our Python code and effectively run it in the JVM. Notably, we can do this for about 0% of our interesting code, but a lot of the code that we write tends to not be very interesting, right? Like we tend to have a lot of simple filters, and being able to push those down into the JVM can give us some really nice performance benefits. Yep. So this is the very fine architecture diagram I came up for PySpark. It's probably why I didn't go into product management. But we can see we've got the Python process on our driver program talks to Java. That communicates to a whole bunch of workers, which are Java processes, and they communicate over a combination of pipes and sockets to Python. Damn it. OK, now, come on. OK, so what are Spark data frames? They're more than just SQL tables. They're not like a lot more. We can think of them as semi-structured tables. And they are different than RDDs because they introduce this new thing called SQL expressions. And so essentially, instead of writing RDD filter lambda x.happy equals true, we can also do this df filter where what we're actually doing is we're writing something in a DSL that Spark will take and compile down. Notably, this DSL is obviously restricted to the things that Spark itself implements. So you cannot call spacey in this DSL, and you can't call numpy or do anything really all that fun. But our simple operations can get pushed down to the JVM. And if our simple operations reduce the amount of data that we're working with, this can give us some really nice performance benefits. Yay, OK, word count the second time. This one is not a licensing requirement. It's just because I really love word count. And so we can do roughly the same thing. And the important part to note is that we can still use our arbitrary lambda expressions intermixed with the SQL expressions. So the group by and the sum here are both Spark SQL expressions. And so those will get compiled down and executed on the JVM, whereas our fancy space tokenizer will get run in Python. And we can see the difference pretty easily. Admittedly, this is a benchmark, and I work for a vendor, so you should not trust me. But I don't really directly make any money, so you may wish to trust me. But we can see here that RDD reduced by key to compute the average in Python is pretty slow. And doing the same things inside of data frames can be a lot faster. And this is really important because a lot of that overhead essentially comes from the fact that getting data out of the JVM and into Python is really expensive. And so if we can get this to be less expensive, our code can be faster, but also we can start to do things that just before didn't make any sense. Clicky button. So we could try and repeat this more generally in a few different ways. One of them is we could use JSR 223, which is a really, it's a fine JSR. Using it is a bad idea, but that's not going to stop me. And let's look at that first. Come on, clicky button. Yay, OK. Right, so for a small price of everything you actually wanted to accomplish, you could make your code run 2 times faster. And it turns out it actually is almost usable, except for the part where it doesn't work with any of the cool libraries. But I have this nice word count demo where I found the word count part funny, where we can see that actually we are able to push down the Python operations and get pretty close to native Scala performance, which is nice, but really not all that practical, because it turns out most of what we want to do is access native libraries, and Jython really doesn't solve that problem for us. So what could we do instead? The actual future, and the future which I'm honestly really excited about, is formats are starting to get better. People are starting to care about being able to take data outside of the JVM and make it available. And Apache Aero is probably the biggest example of this. And damn it, no. Why does this thing only work when I don't want it to? Anyways, and this isn't just like magical vendor pixie dust. Like, this is actually merged into master. If you want to go and check out the Spark code base, you can play around with the Aero integration and the vectorized UDFs that are powered by it. The parts which are like vendor magic is like the part where I promise you this will work for deep learning real soon. And that will probably happen. I did not press any buttons, but okay. So this cat, oh, that used to be animated. Oh well, this cat ate a lot of catnip and is really excited about Apache Aero. This was way cuter when the cat was animated. So we have a similar vendor benchmark. This is from one of my former employers. And we can see that the vectorized UDF performance for really simple things is ridiculously faster. We're talking like 3x faster. And for the complex things, it can be a lot faster as well. In those cases, it's more the fact that it's actually like vectorized and columnar rather than the copy overhead that we're saving ourselves, but it is pretty amazing. And the nice thing is, because Apache Aero is also being picked up by folks like NVIDIA, once we start putting our data in the Aero format, we can use this beyond things like just copying it to Python. We can use this to copy things to the GPU. Oh, and it's important to note that also like R is implementing Aero, so you can use the same techniques to accelerate your R stuff on big data. I want to accelerate this clicker on big data. Okay, so why now? So part of it is Apache Aero exists, and this actually means that these problems are solvable. Before, I would have probably had to spend a lot of time reading the flat buffer documentation and manually figuring out how to do everything I wanted to do. Instead, I can just use the wonderful libraries of Apache Aero. The other important part to note is really what I think has culturally changed is that the people who have been developing these big data systems have realized that if they want to raise their next round of venture financing in San Francisco, they really need to support deep learning. And if they want to support deep learning, they have to be able to get their data onto the GPU. And so things like Aero really change this around. And so rather than it being things like deep learning really change this around. So rather than just being like Python users who want things from the Java developers, now the Java developers want access to the Python ecosystem. And so because we're all aligned, rather than before, we're seeing a lot faster development. Clicky buttons. Yeah, so there's some references. If you're interested in Apache Aero, it's just aero.apache.org. One of my former coworkers did the initial Spark Aero integration. And there's some interesting stuff from 2 Sigma, and the NVIDIA people are also talking about how to use it for GPU acceleration. Okay, these are really the much more important slides because these are the slides where I try and get you to buy my books. So Learning Spark is an introduction to Spark book. It's a little bit out of date at this point, but the replacement really hasn't come into existence yet. If you're a Python user and you're really interested in learning how to work with Spark and Python, Learning PySpark by Denny Lee and Thomas is a wonderful introduction book as well. But really the far more important one is High Performance Spark, because that's the one I get much better royalties on. And it won't advance. Okay, yeah, you can buy it today on the internet. It only has one chapter really about the things this talk is on, but there's a lot of other things about Spark performance in general. I like to think it makes a great gift for cats. They seem to really like the box it comes in. Just please don't return the book after you've bought it for your cat. I assure you, your cat enjoys the book as well as the box. If you're interested in learning more about Spark, the Apache Spark YouTube channel has some really interesting things. Spark Summit was pretty recently, and there are some interesting talks there on the Aero work as well. Paco has a really lovely introduction to Spark talk as well, And the timer turned red, so we're going to hurry up. Right, okay, so we will not go to the bonus slides, but if you are a Python user and you're willing to share your UDFs with me, I would really appreciate them. Then I can start to do benchmarks which are not just like word count and like random libraries and spacey. It would be nice if you could share your real world use cases with me so that we could make them run faster. I understand that perhaps you cannot share your UDFs with me. That's fine. I have to give a testing talk next month again. So if you care about Spark testing, I would love some answers on the Spark testing survey. But other than that, I've got like 5 minutes, and so I was thinking we would save the last little bit for questions. But honestly, I was thinking this room was going to be a lot smaller so I could see the questions. Does anyone have questions? Yeah?
Guys, we have like 20 minutes to the next, until the next talk.
Oh, I've got a bunch of bonus slides if we want to go look at them.
And so we do have time for a couple of questions exceptionally. We are well on time. Anyway, I think, Holden, you're signing books at IBM?
I don't think so anymore. I no longer work for IBM, so they had me do the book signing yesterday at the meetup.
Oh, I see. Okay.
But I am wearing a floor-length sequin ball gown, so you can come find me with your questions. I am
That's true.
not too difficult to find.
Very good. So anyway, Holden, it's been an absolute pleasure. Thank you very much for coming to Madrid today.
Thank you for having me.
Cheers.